Hey everybody. So today we're going to look at data and AEC, and it's not a very creative title, but what we're essentially going to focus on is data within the AEC industry. So leveraging data, just different practical applications of it. More or less, I like to focus around machine learning and actually leveraging data in a practical way. So we'll somewhat try to focus on that. This quote by Edward Deming: "Without data, you are just another person with an opinion," I think is really impactful. It's really important, I think, because data is incredibly powerful when you start to leverage it. It can give you insights on how you're leveraging technology. Are you getting your ROI back by leveraging, these tools, or are you coordinating the way you should? Are you modeling the way you should? Are you, by leveraging data, you could also you're more efficient because you could, a BIM manager, a BIM coordinator, instead of manually trying to monitor and work on, 20 projects, they can leverage the data to help monitor for them. So that data could be looking at warnings within a project or model, could be looking at clash detection or clashes in a Navis model and seeing, hey, we have an incredible amount of clashes all of a sudden. It could be looking at communication within the team to see if people are communicating enough or not at the level that's typical for a certain type of project. So there's so many uses, and it's incredibly impactful. So by not having the data to say, hey, this is how this is happening, this is, this tool is incredibly useful and we should be using it on every project. Without having the data to back that up, it is just an opinion that could be very impactful on the firm or wherever you work. It could be impactful in a bad way or a good way. And the data is going to kind of show you. This image here, this Power BI image, this is just a filler image. I did have a different image here before, a cooler image, but I think this is kind of a relevant image. I couldn't show the other one, or at least I don't think I could, so I'm using this one. I think it's kind of relevant. What you see here is a Power BI dashboard. It's using some of the data that we were able to pull out and just visualizing it. So this is a timeline. This blue line here is just a timeline of how many total clashes were in a project at a specific date. And then you could see it's progressing downwards, and you could leverage something like this with your teams. You could say, hey, or maybe your goal is to hit like in this instance, May 24th, we want to be below 600, which they, obviously hit. So you could use this and project out to say, okay, we're heading in the right direction. And so essentially that's what this dashboard is going to be leveraged as. Currently it's a working dashboard. There's a variety of other visuals associated with it, but as you see, this one here, this one is actually showing I think the electrical clashes for a model. But anyways, some cool stuff. It's incredibly powerful when you can visualize that and show it to people. It's also a little bit easier for people to better understand where they stand. And then, obviously, by tracking that data, you now have historic data that you can start to learn from all projects. To get into this, I thought this was a cool way, or kind of a creative way. I did this presentation about a month or month and a half ago for the firm I work at, and I wanted to do something. So I tried to design this in a way that would be impactful for the people listening. I wanted to show them, hey, here's the phases of the different phases of design. And this isn't all the phases of design, but this is somewhat the primary ones, or the typical ones you'll see. And this is focused. This presentation is going to be more or less focused on design, but it can be, data is, can be implemented anywhere. So you could take these concepts into construction or whatever else. But I wanted to make it impactful. So talk about the designs, what people are used to, because if they're not used to data and machine learning, all these other concepts, it may not hit home for them, and to kind of bring that into what they do every day, I thought would be a great way to show that, hey, this is a practical solution. This is something you can learn from, we can leverage, and we can become better designers by doing so. And now I just noticed that some of these icons are actually not showing correctly. You can see they're hovering. But I'm going to ignore that, and we're just going to keep going through. If you want to learn how I created this presentation, just reach out. I did not use Prezi, though it may seem like that was a tool I used. I actually used only Microsoft PowerPoint. So, but anyways, reach out if you have any questions or if you want to learn how I did that. So we're going to start with pre-design. And what pre-design is the information gathering phase. So talking with the client, you may do a program, which is essentially just what is this building? What is it going to contain? Who are going to occupy it? Just a variety of information. It's kind of just the information planning. And what's awesome is we've done that we've done that thousands of times. We have data. We have finished projects. We can learn from that, and we could at least start to aid people, possibly during that phase, and start to help them plan, by understanding, hey, this is this type of building, you might need this type of team, or you expect to do coordination pretty heavily, because we've noticed these type of projects in the past have increased RFIs, or whatever the case. It can help start to aid that process along, and then reducing variability within projects, so you don't have like almost the same type of project by two different teams, but they're getting entirely different results. You could start to control that variability. Schematic design, so that is the exploring design concept. So this is the part where it's not the design itself isn't totally hashed out, so you're not building a building from this. You're not getting into the details. It's more concepts. So really trying to lay out the spaces and get idea of what those relationships are, and sometimes not even that far. Just sketching out some ideas. And one of the things that we can do is we can leverage GANs during that process. And GANs are generative adversarial networks. And this is a image or two images from NVIDIA, and I think it was a partner between NVIDIA and Gensler. I can't remember who, or if it was Gensler or not, but this is the link if you want to check out and read more about it. But you can see here what it did is it took a database of images, and then it started creating its own images. And what's awesome about GANs, which I think Ian Goodfellow kind of helped develop, or did develop, I can't remember, but and back in 2014, is that you can take a whole set, so instead of just predicting out, what it can do is take a whole set of data, so like images of floor plans in this example, or images of paintings, and it can start to create new data that never existed before by leveraging the data from previous paintings or previous buildings, different images. It can take that start to understand the layouts and stuff, and generate entirely new data. So it's incredibly powerful, and you can do things like this where it generates different floor plans. And during that schematic phase, when you're trying to hash out these different things, you can factor in a lot of the stuff from programming and pre-design into schematic, and you could essentially speed up the process. And get out more designs, and get out better designs, or at least better schematic or better ideas maybe. And I forgot to pop up this image, but essentially this would be your different just images, your data set. So your data set would take in a bunch of images and generate entirely new ones. Design development. So during this phase, you define and develop the project, produce a set of drawings. So you'll hash out a good design. You say, okay, this is the direction we're going, and then you further develop that design. You get further into the details of that design, not to the extent of construction documents, not to the extent of actually building something from it, but you get into more of the details. You start refining those details, and that's essentially what this phase is about. And what can help with that is, again, ML generated plans. So we looked at some of the GANs, which can help with some of the concepts, or at least that example could in the future. GANs could possibly help with a variety of different things. But what I think is incredibly powerful currently is we can look at models, we can look at existing buildings, we can look at existing models that we have, we can learn from them. This Excel document that's right here is just a whole bunch of information about the rooms, what's in the rooms, stuff like that. This below is a journal file, and we can learn how people are using this the modeling tool, how they're laying out projects, and then we can start to automatically generate not just stupid plans, plans that don't make a lot of sense, but actual real plans based off of a specific type of build. So if we're doing hospitality, or if we're doing schools, we could look at every other school, and we could even hone in on a specific type of school for specific types or for specific regions, and then generate plans that generally are with items and elements and relationships that are generally associated with those types of buildings. We could do that by learning from the data, which is what we're doing by pulling in this information, and we can pull in a variety of information and start to generate floor plans. This isn't the greatest image, but it hopefully gives you an idea. Combine that with GANs, and to actually create real models, start to detail out those models. So this up here is Microsoft Azure, or what is it? Azure, or Microsoft Azure Machine Learning Studio. I can't remember it now. But what I use this for is I'll jump out there to kind of just hash out some ideas. So I'll try different machine learning models, and I will see, I'll try to leverage like linear regression or k-mean clustering or multi regression, or just a variety of different things, and different machine learning models, just to test out and see what the outcome is. See if the accuracy is any good. So I'll just kind of test out different models. It's really easy to use. It's just a plug and play. You just drop nodes on there. If you're familiar with Dynamo, it's like that, but even easier. But anyways, I think it's a really powerful tool. It's definitely worth checking out. And I think it's Microsoft Azure Machine Learning Studio. That's it. That's what it is. So just search that, and you'll find this tool. And it's really easy to do. There's already sample data sets and also sample scripts and everything. Another, and this is really cool. This was from Bechtel, and here's the link to this video. And this is just a little snippet of it, but they were doing some 4D scheduling, and if you remember, I mentioned variability. Well, they took a machine and looked at a schedule. It learned what schedules were, and it's automatically scheduled a building, and that's what's this process pipe. I don't know what type of pipe it is, but it automatically scheduled that, and that's. The computer's to the right, and to the left is the human. And it did it faster, but also the variability is more controlled. So there isn't as much variability. There isn't such a range between projects. It's more stable than what a human may output from project to project. So it's incredibly powerful. And excuse me if you hear my dog. He's a puppy. He's barking. So you may hear that ever so often. I may pause it if he keeps going. But anyways, I apologize for that if that's any issue. Construction documents. So that's the next phase. in this phase, just like detailed design, you further it in detail. In construction documents, you take it even further because now you have a more refined design. You have a better idea of you have almost an exact idea of what these elements or items are. Sometimes those things change, but generally this is like, hey, this is what we're doing. This is the layout. This is exactly how we're building this, and it's at the point where you can hand this to a contractor and they can build it. During that phase, what we can do is automatically, create construction documents. So we could look at. Hold 1 second, guys. I'm gonna pause this. Sorry about that. Anyways, I think he was hungry, so he's eating, but he might start barking again. But anyways, guys, sorry. What I was talking about is automating the construction documents. So, what annotation, dimensions, just a whole bunch of different things. And what we can do is, with Dynamo, we can start to leverage and understand the relationships between things. And in this example, what we can do is take a model or take, in this case, what I'm doing is grouping electrical elements, so electrical outlets, to a panel automatically, grouping them to somewhat the correct panel, and it can get us 80% there. And kind of what that looks like is something like this. And I think the actual script is really big. I can't remember exactly what it looks like now, but the script that does that gets us about 80% there. By leveraging machine learning, we can start to look at the actual relationship between outlets and their panels. We can look at how engineers actually circuit those, and then we can start to recreate that, or have a computer recreate that process, and then automatically circuit them correctly, and then tag them, and then dimension them. We can have that go for everything, placing them. And so there's a lot of things that we can do by leveraging machine learning through that process, by just evaluating how people are modeling buildings. How are they creating construction documents? And then we just recreate that through. Because if you think that, you think of like construction documents, okay, it's just tagging some stuff and dimensioning some things, but, the variability, to actually, account for every variable would be incredibly painful, because there's so many things that could impact where a tag goes. And if we can catch that through machine learning, we could start to understand those relationships, or at least a machine could start, and then we could automate it that way. Because if we wanted to start to plan out every single step or every variable, it's impossible to catch all of them. We'll start to get to, extreme scripts where they get incredibly large, and there's a lot of stuff going on, and it just becomes one big mess, and it's very hard to manage. So again, machine learning, incredibly powerful, and can start to understand those relationships. And then here's a little picture of a robot. And then finally, we have construction administration. Again, this isn't all the phases, so not finally, but during this phase, this is while the building's being built, and the design team would assist the builder by answering questions, addressing RFIs and issues, and a variety of other things. And what we could do possibly during this phase is reduce RFIs. So this is BIM 360. This is a model in BIM 360. This is a PDF, and over here it's just some data. So we can understand the flow of that, and understand, we could look at an RFI, understand why that RFI happened, and then have a computer start to learn that process to the point where it knows that this element, this drawing, this whatever it is, may cause an RFI in the future. And we can address that then, instead of waiting until the CA phase. So we could fix this during the design development phase or the construction documents phase, and not until not when that building's actually getting built, because the computer is starting to understand by previous RFIs what actually causes them. And I think a somewhat good example of that is what Bechtel's doing, where they're analyzing all their RFIs, and they understand how long an RFI typically takes to get replied to. Pretty much they understand at that, to that level, what an architect, how long it takes them to reply to a typical, a specific type of RFI, what it is across the entire firm, and then they can start to refine that process, speed it up, build better processes. But it all starts with the data, leveraging and learning from it. And that's what this process is. It's just constant looking at the information in the model, looking at the PDFs, looking at the model. I mean, just constantly learning through that process, and then hopefully predicting out future recommendations and stuff. Recommendations like, hey, move this because this could possibly cause an RFI in the future. And the great, and the powerful thing with that is that we have, so many things, so many previous projects and so many past projects that we have all the data. It's a matter of getting that information and tracking it. One of the big problems though with that is we have so much variability in our data, a lot of differences in it, and there's a lot of missing data. There's just a lot of problems that we have to work around and figure out still, which I think is what makes data in AEC so exciting. So pretty much that's the data life cycle for at least a project or AEC project, or at least an AEC design project. It's a data life cycle, so it's constantly going around and around. What we find in design development can assist with construction documents and so on. This is all information that we can learn from constantly. It's just constantly going nonstop, and as long as we're tracking and storing that information, we can leverage it, for future projects, current projects, and for different phases, and just a variety of different ways. So to kind of get further into a specific example, this is a this is a Navisworks example where I pulled out some data. And this top graph, we have just some clashes. We have in red, or it's above a specific threshold, which just goes right above. It's right at 4K, and I think that one's right, or this number 2 is right below it. But you can see 0 and 1 is ugly. Bad is the column 2, 3, and then 4, 5. This just quickly visualizes that, hey, we have a lot of clashes in this column. Now, this isn't labeled, but let's just assume that this is architecture. So, architecture, we have a ton of clash, or let's do something more relevant. HVAC. This is HVAC. We have 12,000 clashes. This is something we need to reduce down to get to a good level, something below or just below 3,000. It's really quick below, and somewhat what you saw in the Power BI example at the beginning of this. This is just another visual. It's a timeline, and it has 3 different disciplines: HVAC, plumbing, and electrical. It shows you the progression, the timeline, and both these graphs were built in Python. I think using the Plotly extension, or not extension, but library. And they are interactive plots, so you can hover over it and see different information. In the Power BI example, you can hover over that one, see the total clashes for that period, but also see the percentage change from the previous date. So incredibly powerful stuff. You could leverage this to better plan projects. You could leverage this to get a better idea of how, between teams, how people are coordinating their design. You could sit down and see, okay, why is electrical incredibly high and these other disciplines not? Or, well, I guess in this example, let's say HVAC, and let's pretend it's way up here. And if so, if it's, way different from these other ones, then why is that the case? Are they not? Do we need to sit down with them and go through how to coordinate drawings? Are they just modeling their stuff in a 2D plan? Are they opening up 3D views? Are they talking with their other teammates? And if not, then address that. And this is one way to quickly call that stuff out. And in this example, like our goal is March 15th, we need to be below 2,000. Then per discipline, then by looking at this graph, we're progressing in that direction, and you could call out if we're not, and it's above that threshold. So incredibly powerful for planning and actually during a project. This is a really I think this is really powerful. I love this example, and you'll find this article down here. You'll find it how to create this, or at least create that version that he shows in the article. What I've done here is actually switch out the data and also some of the not the features, but some of the data points that we're using. So I'm using like number of disciplines, square footage, and this information, it's all faked. I just typed it in real quick, but or at least in the actual code, the data that this is referencing is all fake. But I typed it in, and you could see that some of this doesn't much make sense. The fact that square footage goes up, but the RFI is reduced. But the idea is that when you find correlations like between disciplines and RFIs, you have more disciplines involved in this type of project, RFIs increase, there's a direct correlation in that. Then you can learn from that and predict. And that's exactly what's going on up here. I type in the number of disciplines, how large the building is, click that predict button, and then this gives me a prediction RFIs down here. And you can see it's no RFIs are being predicted out, or barely even one. Three RFIs in this example here. So this is a faked, or the data at least is faked. But you could see if you start to pull in real information how powerful this is. And again, if you want to check that out, it won't build exactly what you see here, like with the clash information, but it will get you pretty dang close to the point where you'll have where it won't be very hard to start to pull in other data points and tweak the application however way you want. This is built in Python, and it's using the tkinter library. So if you're familiar with either of those, that's what it's built in, and it's really easy to do. tkinter is really powerful, though. It has a lot of cool stuff. And you may see something more on this in the future, but on future videos, but it won't be exactly this. It'll be something more refined. But I think this really conveys how powerful data is, and correlation between data and predicting out. And that's one step. So using linear, and what that was using was multi-linear regression. And so what we can do is leverage that to find predictions, and then and take it even further by looking at the X and Y of clashes. Understand, okay, it went from a active clash to a resolved clash. What happened to that piece of duct? It shifted, a foot over to, the foot over to the north to get out of the way of a column or a beam or something. And by leveraging that information, using data to, extracting that data, that timeline data, and start to understand that relationship between clashes, between active and resolved clashes, look at how people are modeling those changes, and a computer could start to understand that, and then you get to a point where you could possibly automate resolving clashes. So in this example, this beam is being moved out of the column and then below the light or not this beam. Sorry, this is a this is a duct. So it's moving out of the column and then below the light. And if in this example, that may not be the best approach, but a computer could understand that how other people have leveraged or how other people have moved duct to get it out of a clash, how they've moved other elements, how they moved lights. It could have moved the light out of the way and shifted the duct over to the left. There's a lot of things that could impact clashes, and we have the data to show that this is how users will resolve clashes. And as long as we're tracking the information, we get to a point where we are automatically resolving clashes, or not we, but the computer understands that, hey, this is what would this is a clash. I'm going to move it over here and down to get it, make it not a clash, because that's what an engineer would do. It could start to understand that relationship. So these are just some cool examples if you want to get started with machine learning. Teachable machines is a very, very, very basic machine learning application. It's incredibly powerful, but it's very basic, meaning that you can get into it and just drop some images and start playing with machine learning and seeing how powerful it is. Just seeing if it can guess, if it can predict correctly. You could start to see that, and I think it's really powerful. And at least for me, I thought it was really awesome. So definitely check out this tool. The other thing is Microsoft Azure ML Studio, or Machine Learning Studio. It again is really, really powerful. As you saw before when I mentioned it, it's an awesome tool. You can actually build real applications, and I've done so a few times. But mostly what I use it for is just to test out different applications before I go, or different machine learning models before I go into Python. Over here to the right is Dynamo. Definitely get into Dynamo, just so even if it's even if you've heard things like Dynamo's not going to be around that much longer, or Revit isn't, what I think is powerful is just understanding data and relationships. Data is incredibly powerful, and Dynamo works directly with data, so that, I think, in itself is incredibly valuable. So, and this is Python. Python is what I primarily use. I don't know any other language. I love Python. It's my favorite. I spend a lot of time messing around with it. I use Visual Studio Code, or actually, what is it called? Visual Studio Code. So that's what I use as my IDE, and then as another thing that I use is Jupyter Notebooks, which I think is incredibly powerful. It's a nice way to visualize and kind of step through your code. I'll do things in there if I'm trying to figure something out, and then I'll bring it into Visual Studio Code if I want to build an actual application. This example here is actually looping through and setting the projects, or at least it's getting the projects from BIM 360. It's returning a list of projects in a CSV file so that I can see it and then update that information. So it's doing a GET request. If you're not familiar with that, I've done some videos on YouTube kind of talking about that. Down here, this is just working with a SQL database, and I'm pulling out information, learning from it, just trying different things with machine learning and just visualizing the information. But this here is just kind of working with that. That's what this code is here, which I kind of forgot was there. So this might actually, when I show this will be grayed out a little bit of this, because there's some confidential things in there. But check out, I think I'll post the library that works with SQL database, but it's really powerful if you have a SQL server. You can work directly with that with Python, or you can use Python and work directly with a SQL server. So those are the tools that I've used. They're incredibly powerful. Take a look and start messing around with it if you're interested in machine learning. Obviously, this isn't live, so there's not going to be any questions. But if you have a question, feel free to post it below. Ask whatever you want. And this quote here: "Elevate the human experience through data." I think it's kind of cool. If you're familiar with DLR Group, which is the firm I work for, we say elevate the human experience through design. So I just switched it up and used data, kind of for fun. But anyways, if you have questions, feel free to ask them. You can send me a direct message. And if you want to learn how I made this PowerPoint, you could just take the PowerPoints and look at how I created it, because you'll find that below in the OneDrive link. But if you have any questions, just ask me. I'll tell you. It's really easy to make these presentations. So anyways, I appreciate your time, and if you want to hear more, or if you want to hear more videos, on these types of topics, feel free to subscribe. And if you like this video, make sure to like it. And I appreciate you watching, guys. And I'll see you in the next one.